Good morning again, and welcome to Astronomy 100. Today is September 27th, and we are in week 7. And this week is of extreme importance. So from the get-go, let me tell you guys what the discussion item is. It's no secret. It's the exam itself, okay? The emphasis is on the exam this week. The exam opens actually on Thursday. The review ends on Wednesday, which means that you have to do the review, okay, for 2 reasons. First of all, it's a graded assignment on its own right, and it also helps you prepare the exam. So this is the item of the discussion is do the review before Wednesday, okay, before when it's due on Wednesday. So I'm hoping that you guys take care of that, okay? So let me type it. Here, do review for when it is due on Wednesday. Okay. The reason why I'm saying that is I just looked into how many people completed it, and the vast majority did not really do the review. For some reason, I was hoping the weekend would be the time for you guys to do it, but it seems like a lot of you did not have enough time for it. I know I sent reminders, and I'm going to send reminders again. So you really have to do the review. As I was saying, it has its own weight itself, okay? It's a graded assignment. And it's very, very easy. Probably the easiest assignment. You can get full credit for it for doing very little if you want to, okay? I really don't want to see that, but that's actually one of the assignments that you can get quick grades for it without doing much effort whatsoever. So this is one thing. The other thing also, why it is important, and probably that's far more important than the grade for itself in that assignment, is to help you prepare for the exam. What in the world is the exam? The exam has tremendous weight on your overall grade. So that is really the purpose of the review. So I'm hoping that you guys who are watching this recorded session will immediately jump on the review and spend appropriate amount of time on it to prepare for the exam, as it is an essential component of this class. So again, this is the item of the discussion for today. This is item 1. So I'm hoping that you guys will take advantage of this offer. So let me share with you the screen, because we have 2 other things also going on in this week. In addition to the exam, we have, first of all, a new unit, which is unit 39. And that is not part of this exam. It's part of the second exam that is coming also in a few weeks. So unit 39 is not, up to unit 38, basically, that is included in the midterm. However, unit 39 is not in this midterm. Okay, so that is one topic. And it deals mainly as to study the moon. So we're really looking at a way, yes, we looked at the Earth, we looked at in general the planets in the solar system and so on and so forth, and actually not just the planets, the dwarf planets and the asteroids and the comets and other basically stuff here and there, including the sun. But we're going to get into more detail in a lot of those things, okay? We looked at the Earth in far more detail, and that serves us as an example to understand what's going on with the inner planets and actually also with the outer planets in terms of its rocky structure with the inner planets, and in terms of also its atmosphere in terms of how it compares to all the outer planets. We also looked at the now we're going to be looking at the moon. The moon serves actually as another example of inner planets and how they are structured and so on and so forth. And we're going to go through its history and its structure. It's basically how it is made up inside and how it looks from the outside and so on and so forth. So this is the unit 39. And also another thing that is actually this week is introduced for the first time for you guys is projects. The project this week deals with the retrograde motion of Mars. Okay, I'm going to get into a little bit more detail down the road. Today is just an introduction of what the project looked like, okay? So this is basically what we have to cover this week. So let me share the screen. Make sure I'm in the proper class. Yes, I am. Let me share the screen. Share. Okay. So again, we are in week 7. This is the objectives that I'm going to talk a little bit about them. The recording of the session is going to be posted in here, and that is where you're going to post the item I just mentioned about the fact that you need to do the review. And the midterm actually is going to be available this Thursday. It's going to open up this Thursday, immediately after when the review from last week ends, which is on Wednesday. Okay, this ends, this is due September 29th, which is Wednesday. This is actually due on October 4th, Monday. But it is going to open this Thursday. It's going to be available this Thursday for you guys to start working on it. And then the project, which is due in a few weeks from now, in about 3 or 4 weeks from now, so we still have time for that. But because it's a different thing, I'm going to introduce it today. Okay, so that's basically in a nutshell what we have this week to work on. So the first thing first is the review from last week. Again, it is a graded assignment. It has its own merit by itself, and it is something that you have to do. It's not an option. It's not like you have a choice. You may or may not do it. I know a lot of you did not do it, but you still have to do it. So if you don't do it, you're going to receive a mark of 0. Here is the deal, though. Here is the incentive for it, though. If you take it, and I know I mentioned this one several times, and I probably started repeating myself several times now. I mean, I sent you messages and things like that. If you take it, regardless of what you score in it, you're going to get the full credit for it, which is 120 points. Obviously, that goes toward your participation and the fact that you're involved and engaged in the classroom. So that is why it is important. So that by itself is important. And as I was saying before, it is an easy grade to take, to get. You open the review, you go through it, you mark questions, what you think is correct. Whatever you score in there, you score 30 points out of 120, you scored 112 out of 120, doesn't matter, you're going to get 120, no questions asked. You don't do it, you get 0 in it. Okay, so you have 2 choices, either 0 or 120. I take 120 any time of the day. So hopefully you do too. Okay, so this is the review. Then you have the actual exam. The actual exam is this Thursday, as I was saying. It is a timed assignment. You have about 1 minute and 20 seconds, basically 25 seconds to work on every question. Okay, so it's a short period where you're going to spend on it. So the questions sometimes are kind of verbose, kind of long. So make sure you understand them. And then you make your choice about the correct answer and you move on until you exhaust all of the questions. There are 50 questions in there. And there is an allotted time for you to go through the review of all of your questions to make sure you did not miss a single question. Because sometimes in the rush, you think, oh, this question, I'll come back later to it. But then you spend more time on another question down the road, and then you realize, oops, there is a question I missed. So if that's the case, then just go back on it and make your choice on your best guess, okay? And that way you exhaust all of your time, and Canvas will submit it on your behalf if you don't submit it when the time comes, or basically, hopefully you submit it yourself. So that is the exam. As I was saying, Unit 39, which is from this week, is not included in the exam, only Unit 38 and before. All of the units we covered up to that point. So let's look into Unit 39, what we have in it. So let me open the objectives for this week. Again, this is what I was just talking about, the midterm and when it's available and so on and so forth. It's going to open actually at 8 o'clock on Thursday. Here is the deal again with the midterm, and I saw this one, and some of you will skip this advice, and that is not good at all. Take the midterm immediately. Do not delay it. Do not leave it until Monday when it's due. Because on Monday, you will have problems. That's usually typically what happens. You will have emergencies at home, you will have emergencies at work, you will have problems with the computer, you will have problems probably with the card that needs to be taken somewhere and you cannot access something. You will have problems probably with the internet, all kinds of issues that might pop up on that day. Do not leave it till Monday, period, simply. I'm not going to extend it a minute after when it's due. So do not rely on that maybe it's going to be extended. No. So don't work on the exam. Don't plan on working on the exam on Monday, October the 4th. Plan on taking it when it opens on Thursday. That is actually the best way of doing it. Do your review, complete your review. You're confident in your preparation. Then when it opens on Thursday, allocate the time for it, spend the time for it, take your exam and you're done with it and it's out of your way. You have Friday, if in case you cannot do it for Thursday, to take care of it. You still have Saturdays for some reason, if Thursday and Friday are not possible. Worst case scenario is that you have Sunday, and Sunday is really the last day potentially I can plan for. Okay. Sunday, October the 3rd is the last day I should be planning for. Because remember, you have other assignments that are due also, probably not necessarily from this, and there is some from this class, but other classes too. That's why you have to be proactive in your planning on how to do things. That's why you really have to plan these things correctly, okay? Now, Sunday is the worst day to really plan for, but that's the last chance I would consider to plan for. Worst comes to worst, when everything else fails and there is tremendous pressure for other classes that you really have to submit and things like that, you still have Monday, but that is poor planning in my opinion, okay? So this is when it comes to the exam. So again, you're gonna be receiving reminders from me, probably a couple of reminders in between. So that is if you did not submit it. If you did submit it, you probably are going to be skipping those reminders. So again, this is for the exam, which is an important aspect of this class. As I was saying, it weighs heavily towards your grade. So if you're thinking that you want to pass this class with the utmost grade that you need, this is it. This is the place where you need to be. Obviously, as I was saying, we have tremendous asset for this class, and that is the review. So that is actually going to make this whole thing a lot easier. Okay, this week's unit focuses on the moon, as I was saying before. So the moon, when it comes to objects in the solar system, our moon, that is the Earth's moon, is an oddity. It's not normal. It's an exception. Okay. So we need to understand where that exception came from. The Earth's moon, I mean, if you look at Mars, I mean, if you look at Venus and Mercury, they don't have moons, and those are inner planets. Especially size-wise, Venus is probably the best comparison. It is a twin sister to Earth in terms of size. It has almost the same diameter, almost the same mass, almost the same basically structure inside. So it's almost the same gravity as the Earth, okay? I mean, there are some differences, and the biggest difference is the atmosphere. One of them has a lot thicker atmosphere than the other, but that's just a minor difference. Venus does not have moon, Earth does. Okay, that is one thing. There is an indication to something might have happened early to Venus, similar to what might have happened to the Earth, and that is Venus actually spins extremely slowly around its axis backward, okay? Meaning that the sun rises in the west and sets in the east, as opposed to what happens on the Earth. So that is an odd thing. And that reverse motion could be explained that probably what happened to Venus was it collided with an object. Everything must have happening in the same, going in the same direction. So the only way for something to be moving backward is something must have happened to early on to it. And that is an indication to what this moon for the Earth is. Maybe also from the early history of the Earth, what happened to the Venus might have also happened to the Earth, with the exception that the result of that event, there is also then a moon for the Earth and for the Venus in a backward motion, basically backward rotation, backward spinning. Okay, that is one thing. Mercury does not have a moon. Mars has a couple of rocks, if you want to call them moons. They are captured asteroids, and that is basically it. So the Earth has an odd object revolving around. It's a big one. As a matter of fact, it's far more massive than Pluto. Okay, so it's a big moon, relatively speaking. So this is something that we need to understand. So there were attempts trying to explain the origins of the moon. One of them, that could it be that the moon was a captured planet that was revolving around the sun, and then instead of continuously, because it was close enough from the Earth as it was going around the sun with the Earth, then it was captured by the Earth, and now it starts to spin around the Earth. Just what would happen, for example, with Mars and its couple of moons. Well, that does not work well, because the density of the moon should be then, in that case, since it's forming the same neighborhood as the Earth, should be similar to that of the Earth, and it is not. As a matter of fact, the density of the moon is about 3.3 grams per cubic centimeters versus that of the Earth, which is 5.5 grams per cubic centimeters, indicating a far poorer object in terms of iron constitution. And iron must have also formed in all of this region with the same proportions, but so how come it's not the same for the moon? So there is a problem with the structure of the moon, number one, okay, compared to that of the Earth. So that does not explain that theory. Now, could the moon be part of the Earth, had been part of the Earth all along, okay? And somehow the Earth was spinning so fast that it lost some of its crust. Well, if that's the case, also the composition of the moon does not support that theory, because the crust, we know its composition, but the moon has a different structure than that. So it's really a hybrid approach to this whole thing. And the leading theory is that the moon must have formed by a Mars-sized planet that has collided with the Earth. There are all kinds of support for this theory. Okay. First of all, it explains the structure. During the collision, most of the material that was ejected must have happened from the crust, but there was some also materials from the original planet. So that gives you that mixture in terms of the composition, the right picture, if you wish. So the models support that. It also, based on the current observations and what we see in terms of rotation of the Earth, and at least from the migration of the North Pole, the magnetic pole that is, it seems like there is a part of that collision that has sunk deep into the core of the Earth, and that created an asymmetry that can explain the different points in the rotation of the Earth. So that itself also seems to be a supporting evidence for this collision. So part of the material that came from that collision actually is still differentiating and still going inward into the core of the Earth, and the other part, of course, it was ejected and then later on coalesced from smaller and smaller particles to bigger and bigger particles to form what is currently the moon. So that explains the structure, explains what happened to the Earth. There is also another thing that is related to the last item in here, and that is the motion of the moon itself, the rotation of the moon and how it spins around its own axis. It goes the same period as it goes around its own axis. It's the same time it goes once around the Earth, meaning it gives you the same face as it is moving around its own axis and moving around the Earth. So basically, because of that synchronous motion, the moon ended up with the same face, the face facing the Earth. Well, which face is, because of symmetry, either face could have been, we ended up with this face, basically, because there is a slight difference in appearance between the two faces, and one of them has actually a different distribution of this dark regions of the moon versus the bright regions of the moon. So this is basically something. So there is one side that we can never see, at least from the vantage point of the Earth, unless we go like the astronauts did and went around the moon to the other side and basically took images of it to see the other side of the moon, okay, the hidden side of the moon, if you wish, from the Earth. So this rotation in here has an issue. Okay, all the planets, including the Earth and the Moon, for the most part, are actually, for the most part, living on the so-called ecliptic plane, and that is due to the conservation of the angular momentum as a vector. Okay. Now, the Earth is tilted by 23 degrees from that axis, and we needed to explain that. So part of the explanation is probably due to that collision. But more so, what that collision did produce also, actually, there is another tilt for the Moon as it moves around the Earth. It does not stay on the equator of the Earth, which is tilted with respect to the ecliptic. It has its own basically motion around that direction, and that varies between 18 degrees and 29 degrees. And that, according to the numerical models, so the numerical simulations, fits beautifully with that collision, with a model collision of a planet size, Mars planet size, basically. A planet of the size of Mars, basically, called Theia. Actually, if you look at the literature, they give it a name, which is Theia. That planet, which must have formed in the same orbit as the Earth, because it was close enough from the Earth, and that led to a collision with the Earth. So that collision produced all kinds of effects that can explain the structure, explains the motion of the Moon, explain the motion of the Earth, explain what's happening actually inside the core of the Earth. So that model fits beautifully, and it seems like it's perfect. As a matter of fact, if you look at the rocks on the Moon, when we brought them from the Moon and we dated them based using radioactivity, this collision must have happened immediately when the Earth was formed. As a matter of fact, the Earth did not cool enough. It still has a lot of energy from the early materials when they came together because of the loss of the kinetic energy to, I'm sorry, the loss of the potential energy towards kinetic energy, and that led to a lot of heat that formed. So the Earth was still extremely hot at that time when the collision happened. The solar system, including the Earth, formed around 4.5 billion years ago. This event that I'm talking about was 4.4 billion years ago, because if I look at the structure of the rocks in here, some of them date to that far in the history of the Moon, okay? So this is when the event must have happened. As a matter of fact, there is a discrepancy between the dark regions, they are called Maria, on the surface of the Moon, versus the bright regions, and the bright regions are really the highlands that you can see in there, and they are bright because of the different compositions. This is mainly basaltic rocks in here, indicating that they must have formed during some sort of a lava flow when the Moon was too young and still hot enough that it has volcanoes or lava flowing from the inside the surface, and that is basically what this structure is. Whereas this one's, the highlands in this case, they were kind of far away from it, and they retain their reflectivity with respect to the sun, from the rays coming from the sun, and have different chemical structure. They have aluminum and other minerals in it and other rocks in it, and that is basically the main difference. In addition to the surface is actually littered with impacts from the different impact craters from the different basically asteroids that must have hit it during its history. And this, if you look at the proportions of them, they are far more dense, and the separation between them is very small on the bright regions versus that of the dark regions, indicating that this lava flow must have happened later on or during this impact craters, which erased a lot of them. That's why you see them less dense in here than in this region. So that is basically the outside structure of it. So in addition to this impact craters and to the highlands, you have this rays in here that you can clearly see some sort of a flow also of this lava flows that is coming from the volcanoes from the early Moon. So the early Moon must have had a lot of geological activities from the inside, because it has, again, similar to what the Earth is, a lot of radioactive activity inside of it, mainly from potassium and other minerals, but it ran out quickly, so that there is very hardly any kind of geological activity nowadays. Whereas the Earth is still an ongoing active geological planet because of the fact it has more material of those. So it's still hot inside to produce all kinds of activity on its surface, including the plate tectonics and everything else on the Earth. the moon is still kind of has some activity due to two main things, because it still has that remnant heat, but it's still very weak to produce much activity. But it has another thing that is due to this motion of the moon around the Earth, where the moon, excuse me, the moon and the Earth are tidally locked. Excuse me. So the Earth must have been spinning faster than what it was today. There are all kinds of indication for that. Same thing for the moon. But because of the tidal locking, basically, they came at resonance at some point where this activity now is in sync. That gave us the fact that the moon always has only one face facing the Earth. So this must have slowed down the moon. As a matter of fact, it's slowing further because it's actually moving away from the Earth. So it's the motion is actually slowing down every year. This tidal locking, the fact that you have tides on the surface of the Earth because of the the oceans are kind of a little bit easy to move, but on the surface of the moon is actually the surface of the moon itself is basically tidal lock. It's being pulled from one side and the other, and it's flattened from the other, like you're kneading, for example, the dough when women work on the dough. Or man, it doesn't matter. I'm sorry, I'm not choosing. When somebody's working on the dough, trying to knead it, that's exactly what's going on with it. So that produces internal heat, which produces actually activity on it, resulting in the moonquakes. That, the moonquakes, gave us an insight into a structure, its internal structure. Seems like the moon has also a core, with an outer core that is actually liquid because of the high temperature. And its composition is slightly different than that of the core of the Earth. It's not mainly iron like it is on the Earth. It has some other silicates and other materials in it. So that is why it's kind of it melts actually at a lower temperature, and indicating its structure. And that's because of the density is overall is less than that of the Earth, as I was mentioning before. So it has a core, it has a mantle also, and it has a crust. The problem with the crust on the moon is it's mainly made out of rocks, of course, and also out of dust. And the dust is made up mainly of the different impacts that basically scattered throughout the moon. The thing with that is that it does not have an atmosphere. There is no water. There is at least no atmosphere in it. The water that exists in the polar caps of the moon. So this is overall in frozen solid rock, basically, so ice form. So it's not liquid form. So this is basically the different things that we have in this chapter. What I'm just mentioning in here is the overall of this chapter, or at least this unit. You're still required to go through the materials yourself and read through it and find all kinds of fascinating facts in there and interesting studies in there. So that is what you're going to be tested on. There will be no quiz on this unit. There will be no homework yet on this unit because of the fact that we have already our hands full of a big time assignment, and the assignment is, of course, the exam itself. So this is in a nutshell what's going on inside this unit. If you guys have any questions, please let me know. Hopefully you will go through the materials and you finish, after you take your exam, you go through the materials, and if you have any questions, please ask me. Let me go back into home in here, because we still have this thing to talk about. I'm going to open it, look at it. I'm still signed in as a student, but of course I'm going to open it to see exactly what's going on. So I'm going to open it as a student. It says that it's due October 23rd. So let me open it to see what's going on. And I don't see it. Obviously, because I'm logged in as a student, but what I see in here is something very, very valuable. It tells me how this assignment is graded. It gives me the rubric of how this assignment is graded. The rubric is actually a very useful tool in here for you guys when you're submitting your report, because you can go through the rubric and see what it's asking you to do. And once you do that, if you do it satisfactorily and you think that you did it right and everything looks good, you can put yourself a check mark in there, and you know exactly how much you're going to get in it. As you move on to the second rubric, so on and so forth, you're going to have all kinds of different items in them. until you're completely done with it, and you look at the last rubric and you know exactly how much points you are going to have in this assignment. So this serves as actually a blueprint for a report if you want to. Put it aside next to you while you're doing your project report, while you're working on project report, and make sure you look at this one. It says do this, and actually go and do it, and then look at it. Does it look right? Then this looks good. Then I can go and move on to the next item. Okay, I put check mark on this one. I look at the next item. It says to do this. Then I'm going to go in here and take care of it. And then once I'm satisfied with it, I go back and put check mark and so on and so forth. The rubric is actually a very, very useful tool. Since I cannot see it right now because it's due on October 23rd. I mean, it's actually available on, when is it? Monday of next week, October 4th. Okay. I'm going to leave the student view to see it because I can see it as an instructor in here. Okay. In the instruction, it has two things on it, two links in it, if you wish. Of course, you have the rubric in the bottom in here, but it has these two links. You have this PDF file, and you have the instructions, the actual project itself, okay? The PDF file is not mandatory. It is actually an option because of this word. You may submit your report using this lab report form, this report form, okay? So you can choose to use it. If you don't like it, or if it doesn't work for you, you don't have to use it. You can use whatever other format, like Word file or other options that you might have, as long as you take care of it, as long as you submit your report. It's a good idea, though, to look at this form because it serves actually again as a frame, if you wish, for doing your report. Okay, so if you can do it, that's actually good. But if you can't, for some reason, it's not saving or it's not working for you or something like that, please do not message me and tell me that I cannot do the PDF file, therefore I cannot do the project, because it's not required. You can still use Word or any other thing in there to do it, okay? So it's not required that you have to do it, or else you're not going to have your lab or your project report, okay? So this is not a must, okay? Now, if you choose to do it, this take care of that. That's sometimes one of the problems that you run into, okay? So let's open this link to see what's going on. So I'm going to open the link to see what are we talking about. It was one of you guys who sent me a message. I don't remember exactly which section, but sent me a message about this retrograde motion of Mars. The title of the project itself is on the retrograde motion of Mars. And that it has some dates in here with some useful links and things like that that you can look at and do the answer the questions. And we're going to go through that as we look at these things. We're going to get into more detail down the road about this one in here. Okay, so this is not the full view on the project. We're going to dedicate a whole session just for the project itself. So this is the retrograde motion of Mars, but instead of just Mars, it's listing other objects in the solar system, namely Mercury, Venus, of course, Mars. That's what triggered the whole thing. And you have Jupiter and Saturn. Those are planets. But in addition to the planet, I have this dwarf planet in here, Ceres, okay, which is in the asteroid belt between Jupiter and Mars. Okay. What it is giving me in here is giving me their period in months. How long does it take for them to go once around the sun? That's what the period stands for. For Mercury, it's 2.89, almost 3 months, okay? Obviously, this data is from the year 2020. And the next one from this data is in the year 2021 or probably later on, okay? So if it asks you for the next, it's going to be after this date. So this is the last occurrence, the recent occurrence, if you wish, from the year 2020, when this basically retrograde motion started. For the case of Mercury, the data that we're given in here is from February 26, 2020. The next occurrence after this one is when you're going to be calculating, okay? You're going to compute how many months, and you add it to this month, and you're going to find the number in here. Okay, this TE in the formula stands for 12. TE is the period of the Earth. So when you see TE in this formula, it's 12. When you see this T, it depends on which object we're talking about. If it's Mercury, T is 2.89. If it's Venus, T is 7.38. If it's Mars, T is 22.6. If it's Ceres, it's 55.2. Wow, almost 6 years for Ceres to go once around the sun, where the Earth went almost 6 years. Okay, that's what this number is meant. 55.2 months. For Jupiter, it's 142 months. So if you put T in here, 142. So what I do for Jupiter, if I'm doing Jupiter calculations, I take 12, that's for TE, times 142, whatever the calculator gives me, divided by 12 for the Earth minus 142. 12 minus 142 is negative 130. So whatever I find from the product divided by negative 130, I'll find an answer in there. Here is the trick. When you see this bars, the negative, do not write it. These are called the absolute value. So when you see an absolute value, that means that whether the answer is negative or positive, you're just going to report the answer, and that's it. So do not write a negative number. So for the case of Jupiter, it's going to be negative because I have 12 minus 142. That's going to be negative 130. But I don't write the negative in here. I just write it 130. End of the story. Whatever 12 times 142 divided by 130. That's the answer for S. All I have to do is whatever I find, I have to add it in months to this one. Okay. Again, we're going to get into a lot of detail down the road. For the case of Venus, it's going to be a positive number because 12 minus 7.38, 12 minus 7.38 is going to be positive. So I don't worry about the sign. Okay. So it's going to be positive nonetheless. Okay. So this is we're going to discuss this one down the road. So if you're confused about this one at this point, don't worry about it. We're going to get into far more detail down the road. Let's look at this question in here that some of you asked about the geocentric model, where the Earth is the center of the solar system, and about the heliocentric model, where the sun is the center of the solar system. I'm taking in here the rotation of the Earth around the sun, and I'm taking the rotation of the Mars around the sun. So the first inner circle is that of the Earth, the outer circle is that of Mars. Here in the geocentric model, everything revolves around the Earth. So there is only one object in this case is Mars. We want to find Mars and track it down. So Mars goes in a circle around its center point, and that point goes by itself in rotation around the Earth. So this point 1 is part of a circle that I'm not drawing in here that is centered somewhere in here. So point 2 is centered in here, and that is the axis of center in here, and that is where the rotation. Point 3 is somewhere in here. Okay, there is another circle probably in here. So, and that is a circle that goes around on different points in it. Point 4 is probably centered in here somewhere and is going like this. Point 5 is centered in here somewhere in here and is going like this, and so on and so forth. Imagine with me, this is basically the different point. 11 is somewhere in here, circle that is going around in here, somewhere centered in here, and this distance is the same, okay? But that doesn't really matter that much. All that matters for this view is if I am on Earth looking at Mars, on this day, for example, I'm going to see Mars as projected on the sky in here, somewhere in the sky, versus the other planets, the other stars in the sky. So it looks like Mars appears to be here, this point in the sky. If I take a line and draw a line from the Earth all the way to 1, it's going to meet the sky somewhere in here. If I take the Earth and draw a line in here, it's going to meet the night sky somewhere versus the background stars somewhere in here. So Mars looks like it has jumped from here to here in the night sky. If I draw a line from the Earth to 3, Mars has jumped from here to here. So Mars was here, then moved in here, now it's in here somewhere. for 3. And I'm going to draw 1, 2, and 3 in there. That's how it looks like in the night sky. 4, it has moved further in front. 5, it has moved backward, actually. That is the retrograde. It starts to move backward compared to the stars in the night sky. 6, it has moved backward versus than 5. 7, it has moved down also. 8, it starts to move forward again. 9, it moves forward. 10, it moves forward. And 11, it moves forward. So that is the retrograde motion explained in terms of the geocentric model. Okay? Where the Earth was the solar system, where the Earth is the center of the solar system. Of course, we know that's wrong. But that explains the retrograde motion. Of course, it doesn't explain all the things. That's why it's good just for the retrograde motion of Mars, but not good for everything. Okay? There are a bunch of questions that you need to understand, to answer in here, and we're going to get to them. Let's look at the retrograde motion now from the vantage point of the heliocentric model, where the sun is actually the center of the solar system. Here is the sun. The Earth is spinning from position 1 to position 9. In the same time, the Mars is spinning from position 1 to position 9, with the exception that Mars is moving extremely slow. Remember, Mars does 22.6 months for 1 year on its cycle, whereas the Earth does it in 12 months. So Mars takes a lot longer to go once around its axis, around the sun versus the Earth. So in the same period that the Earth goes from this position to this position, a bigger arc, Mars draws a smaller arc. In the same fashion, I'm on Earth. I'm not on the sun. I'm just looking at Mars. So I draw a line from position 1 to position 1, and I see it projecting in here in the background night skies. From position 2 to position 2, where the Earth now is in position 2 and Mars has moved to position 2, Mars appears to have moved forward. So it was initially down, now it has moved forward. From position 3 to position 3, it has moved forward still. So I write 1, 2, and 3. From position 4 to position 4, it has moved slightly more, okay? Or, yeah, slightly more. It has slowed down. It has jumped from here to here, now here, now here, okay? From 5, it looks like it has moved backward, actually, okay? Because I draw from 5 to 5, it's going to be straight out line in here. From position 6 to 6, it's going to be backward. From position 7 to 7, it's going to be slightly backward, and then it's going to start moving forward again, okay? So the heliocentric model can explain also the retrograde motion of Mars and all of the other planets. Okay? As I was saying, Mars is not the only object that does this retrograde motion. All of the other objects do that too, albeit because of their proximity from the Earth and not to, their motion is not as clear. I mean, the clearest one after Mars is actually that of Venus, because its proximity from the Earth. So you can clearly see the backward motion. As the objects go further away, the motion becomes a little bit less accentuated, if you wish, but you can understand it. We use this geometry because some of the planets are on the other side of the Earth from the sun, and others are in between the Earth and the sun, like Venus and Mercury. So we have this geometry, and we can explain the different rotations with the geometry. Obviously, the opposition is on the other side, conjunction is on the other side, and you have basically the different positions in here and the different angles. At this point, I don't want to get into a lot of details in here, and it's not even available yet, but just to give you a feel of how the project is going to look like. You're going to do calculations, you're going to be doing drawings, and you're going to read through this and read through the book and answer the questions as they should. And then if you have any questions, you let me know. So this is in a nutshell, just an overall view. This is from very far away looking at this project and how it looks like. Let me go back to the student view. Go back home. Again, this is the week. By far, the main thing at this point in here is the midterm itself. We still have chance to do the review, so please do it. And prepare for the exam. Now, down the road, I will dedicate a whole session just for the review, for the project itself. And of course, we'll have homework and we'll have quizzes and other things. But at this point, the main thing is this exam. Okay, and because of its tremendous weight. Okay, If you guys have any questions, please let me know. I always answer them quickly unless I'm tied up in a meeting or in something else. On the weekends, sometimes there is a little bit of a lag of a few hours at most, but most of the times I get back very quickly to you guys. So if you have any questions, please let me know. I already sent a message this morning at 7:30 in the morning for all of you guys concerning this Thursday. I will be on campus, and because of the limited time I will be in, I will be all morning at least there. So if you want to meet, yes, to answer the question on the chat, I did, yes. If you don't find it, please let me know and I will check on it, okay? Okay, let me check on it since you mentioned that from last week. Oh, for some reason it's not showing. Why? Thank you very much for mentioning that. Nobody else mentioned it before. So it seems like the recording is not visible for one reason or the other. Let me leave the student view to see what's going on with it. I thought I did them all. Huh. Let me check exactly to see why it did not work. Question is, what happened to the session from last week? Of course, we had a live session last week too, where we went through the all of these things, and from week 6, and I have it actually posted on YouTube. That's why it's a good idea to subscribe to the YouTube channel, because sometimes like this one thing happened, and you will see it on YouTube before you see it actually on Canvas itself, which it should not really be a requirement, but for some reason it happened this time around. So let me go back into the course, section 08, week 6, edit. I grabbed the link from last week, that's all. And paste it in here. Let me grab the link, Control X this. Thank you, Jesus, for mentioning this. And if it was not for you, probably nobody else. Can you refresh? Oh, no, hold on 1 second. Can you refresh the window now?
Yeah, I'm trying to do it right now.
Okay.
Yeah, it works now.
Okay, beautiful. Thank you for mentioning that. Hopefully everybody else also captured this one, and that let me check something quickly here, because I want to check the reviews on this video in here to see if it was from last week, section 108. Yeah, no wonder there's only few people who looked at it. Those who were subscribing to the channel, to the YouTube channel directly, where I had notifications to it. For those who did not see it. So it's a good idea to subscribe to the channel. It doesn't cost you anything, just to make sure if something like this one happened, you don't miss any kind of assignments or at least any much of recording. And I'm sorry for this not having checked on it again, because usually I post the links immediately after I post them. And for some reason, this did not work. Let me check if there is anything else in there. Section 9, section 7. Looks like section 6. Week 6. Looks like this was the only one that was a problem. Anyway, please take care of the exam. It's very, very important that you do that. And I will be, again, as I was talking about, I will be here, I'll be on campus on Thursday. So if you really want to meet this Thursday, when the exam opens, actually, I will be on campus. Please send me a message to the effect, and so that we schedule a meeting, because of the limited time when that is available, because there are so many sections, whether in this subject, astronomy, or the physics classes. And I send the message to everybody. for all of the different sections, different classes. So it's not just for one specific section or anything like that. So if you choose to meet, you have to send me a message as soon as possible, hopefully before, not hopefully, I'm requiring it has to be before Wednesday noon, so that I can have my my day planned properly for Thursday, because I have to meet also probably with all the department faculty. So again, please send your message as soon as possible so that we can meet and answer whatever you need to do. If not, then I'll see you online. I'm going to stop the recording.